So today we have two fantastic speakers. Our first speaker is Marcus Paine. Marcus is the founder and managing director of Hutton Stone, established in 1994. Hutton operate 3 exclusive sandstone quarries with state-of-the-art sawing and production equipment, and also stock over 20 further British stone types to serve their wide client base. In 2024, as part of focus on sustainable future for natural stone, Hutton launched their natural stone Darnay bricks, a new sustainable construction product with a fraction of the carbon footprint of clay-fired bricks. Most recently, Marcus has become the president of the European Stone Federation, EuroRoc, and continues to advocate the idea of a new stone age to a new generation of design professionals. Marcus's talk will then be followed by Pierre Bidaud. Pierre is the creative director of the Stonemasonry Company, a specialist design and fabrication firm known for its pioneering work in load-bearing and post-tension stone structures. A stonemason for over 30 years, Pierre has taken his craft and passion for stone from France to the UK, bringing deep technical expertise and enabling technical innovation and collaboration with leading architects and engineers. Through landmark projects and ongoing research, Pierre has been instrumental in redefining the role of stone in modern architecture. Together, Marcus and Pierre are founding members of the Stone Collective. The Stone Collective is an initiative group of industry leaders committed to promoting stone as the sustainable, low-carbon and load-bearing building material for the 21st century. Their mission is to educate and inspire the construction and design communities on the benefits of load-bearing stone and natural stone bricks. I'd like to introduce Marcus for the first of the talks for about 20 minutes.
Thanks very much, Stephen. Can you hear me okay? Everybody okay? So, assuming you can, many thanks for having me along for this brief overview and to spend a little time looking at the process we engage in the extraction and production of natural building stone, how that can inform specifying the material, and also look at what drivers led us to think about stone in a brick format. Okay, and so bearing in mind that this is a whistle-stop run through the subject in broad terms, I should simply start, I should first point out that right from the start, we humans have picked up pieces of stone wherever they were available and successfully used them for building things. And as Scotland here beautifully demonstrates, our particular island is the result of as diverse a set of geological circumstances as exist anywhere on Earth, which, along with other geological circumstances being true elsewhere in the world, has significantly affected and influenced how humans in any particular place have practically used the material at their immediate disposal. And this again in the UK as an example, should you look on any Brit-picked map, resulted in an incredible and vast array of historic quarries, pits, mines and extraction sites across the whole of the country, providing us with the vast and varied built history that by and large surrounds us wherever we are and defines our heritage. These in the UK and elsewhere were mechanised and further developed throughout the 18th and 19th centuries, and adapted as other technologies came to the fore, and only faltered and fell away from around the start of World War I, until they were to a great degree, certainly in the UK, abandoned by the start of World War II, as social, political and other needs changed in conjunction with cheap and plentiful energy, that's cheap coal to you and I, boosting the credentials of other materials. And that gives us a very potted history of the immensely varied buildings we can still see today, from humble to incredible iconic buildings, castles and monuments, now many hundreds of years old. And to note, very much the historical, sustainable and economical use of material, almost always evident in the form of more elegant frontages and rubble elsewhere. There is the humorous but relevant historical statement that states, the further you get from the front door, the poorer it gets, which in actual fact is a simple reflection on the economical and sustainable use of the material that was dug and prepared, driven throughout history by cost and the need to use it appropriately, but is now an important keynote in the lesson of how to use this material in the future, where we must align cost as ever, but with low embodied carbon now necessarily a critical factor. Sorry, just slightly lost there. And also to note that historically, the material at hand more often than not dictated the architectural process employed in its building, and hence the very essence of the area or the district. Next, it is only fair to say that in order to make a natural material sustainable and economical, and up until, let's say, 150 or so years ago, tonal range and variation, colour, etc., was largely ignored as the material at hand was used to fulfill its practical role. This slide, showing Carboniferous sandstone in Alnwick Castle, was at the moment of extraction around 290 million years old, and hundreds of years later, with pointing maintained, it remains very reliably still here. When freshly worked, though, it must be understood that it was all sorts of everything in terms of colour. And in a reasonable amount of time thereafter, nature simply toned it down to what we see surrounding us across the UK today. The point here is that to judge a natural product that is millions of years old on a brief speck of its lifetime, when it is temporarily sawn or dressed clean and arguably at its ugliest, makes no sense in an economical and sustainable future. These sawn blocks, all from the same quarry, the same face, even the same block, simply show in starkest terms what our built heritage may have looked like when first built. And yet we know, because we have the benefit of hindsight, that given a surprisingly short amount of time, natural stone weathers in and tones down entirely. And so the lesson for the thrifty, sustainability-driven, enlightened is, when looking at natural variation in new, fresh sawn or split stone, be open to the material being aesthetically interesting or exciting, rather than the 20th century concern that it was challenging or concerning, which led to enormous selecting out and sanitization of this natural inconsistency. Purposely rejecting nothing in terms of range and variation in a natural product utterly transforms wastage and product cost, and further lowers product embodied carbon score too. In essence, the material should be judged by the well-informed with the allowance of seasoning and aging, rather than looking at palm samples of new stone and trying to control the outcome of a natural process that rewards the patient recipient. So on then to a quick glance at quarries. Some managed to remain open throughout the diminishing of the industry as other products rose to the fore. And as stone has latterly found more popularity, albeit as a clean, thin veneer on more modern buildings, then other quarries have again reopened. A small fraction of what previously existed, currently around 300 in total in the UK at the moment, but most with a long proven track record. And in Europe, it should be noted that whilst we in the UK chose to continually develop our taste for man-made options, the French in particular chose to revert back to using low-cost natural stone as the basic load-bearing material to great effect many decades ago. Open cast quarrying from the top down, as shown in this image, working the available beds in the geology, which higher up generally provides walling quality material, whilst deeper down, large blocks suitable for masonry. This is a nod to history and sustainable material use. If you dig it, use it. Hence ashlar facades and rubble gables and rear elevations. It's all endlessly explained to us everywhere we look in our built heritage. Drilling and hydraulic or powder splitting. This image shows how, using ultra-modern machinery, we drill the faces very accurately. And rather like how we can tear a page from a jotter notepad due to the holes that allow us to tear it accurately, we remove block in a very low stress and economical way, and in so doing aim to transform our UK quarries further reducing input energy and output gains. These blocks on the right, with Carl, one of our quarrymen, stood on them, are circa 40 tons each, and are next split again into workable 10 to 14 ton sizes. Working with natural jointing, removing blocks for maximum yield in any natural geology, and project unit sizes that work around the most efficient use of the material, the key as ever. Controlled splitting and techniques handed down the trade within all geology versions of extraction are not lost within this industry. It's just that they have not been required for a period, whilst the whole cost of making man-made stone equivalents has simply been irrelevant. Here we see controlled explosive splitting at the exact moment of detonation, which in this case yields a circa 120 ton primary block, and also a block simply split by hammer and hand using plug and feather wedges. Here, the plugs and feathers shown in action, splitting the stone and the end result. Mines too, this one digging Portland limestone, are as developed and sustainable as technology will allow, and ensuring material remains available for many years to come. Sawing clean base bed directly from the face, but also a host of other beds that are instantly and economically relevant if we accept the perfect imperfection of the natural material. Thereafter, blocks are selected for suitability and run through production facilities, producing bespoke and mass-produced products as required. Primary block sawing, think about it like cutting an uncut loaf of bread from the baker's and making it into a sliced loaf. Economical wire sawing, now including complex CNC options, a modern feature of our industry. Here aptly demonstrating how every block, big or small, is used for its appropriate dimensions. No waste, always the fundamental industry target. And then with these slices or slabs of block, we turn them over and lay them on smaller secondary saws to either cut to final square dimensions or mill and shape as required. Masoning. Architectural features used sparingly but functionally to throw water away from the building. Surface dressings, often critical in heritage work, again perhaps used very selectively as a simple method of creating a front door definition to a building. And of course, carving for those special pieces, all part of the story. Sometimes now by CNC, but always where necessary by hand is of course still possible. And so that's where we are. In many ways, a declining industry, hooked and feeding on endlessly bespoke niche items and restoration. And my friend and colleague Pierre will elaborate on why and how the outcome was somewhat different for Europe. And it leads us to understand why a few of us, somewhat disillusioned with the current status quo, chose to think outside of this box and align the principle of a mass-produced natural stone brick as nothing more than the 21st century version of a piece of Victorian rubble walling, in an effort to align concerns for our climate with our almost forgotten natural material in its most utilitarian form and how we perceive it going forward. In terms then of specification, and in the current construction cycle, where cost and specification is often manipulated, and where this bespoke nature of what we are asked to do is often at odds with the program or the control of it in any project. We would simply say that in terms of specifying natural stone for your project, embrace the ideals and lessons of the arts and craft movement. Understand the material, engage early in the process with your chosen supplier. The nearer you can get to the source, the more likely you are to retain control of schedule and cost. And the more people you have in that supply chain, the more likely you are to be frustrated. The creator, that is the architect, the designer, the visionary, and the maker, that is the producer of the natural product, are divided and conquered for commercial reasons. And we would argue that at a time when we need to rethink our future buildings, combining lower cost and lower carbon outcomes, that the connection between the two trades is more important to resurrect than ever. So the stone brick journey was initially inspired by hearing Pierre and Amin Tahar on a Stone Federation talk chastise the UK stone industry for its failure to develop and its inability to be competitive with imported alternatives and man-made options. And whilst I observed many of my contemporaries smart with indignation at the suggestion, I, having spent my career very much in the thick of it, felt this really resonated with my feeling that my industry had sleptwalked into this perceived position really since the World Wars, where we societally rejected much that had gone before in favour of various high input, quick, convenient economic alternatives that ultimately also led to short-termism within our buildings. And whilst that was in many ways fair enough, it had no reason until now to consider the climate outcomes of the high input energy needed to create the products that gifted us the way forward. It really was about embracing the idea that the mass production of one building unit, which the clay brick industry had so successfully done, and in so doing had eclipsed the natural rubble walling market almost entirely, could, as an entry point, reinvent the general perception of natural stone. Now not just for the beautiful bit of a building, but like rubble before it, for the most basic, cheap building element and low embodied carbon too. And so we began a slow and steady process of demonstrating what this could look like by producing demonstration pieces for exhibition, showing stock brick sizes and how easily we could make specials too. We hosted and supported many talks, tours, visits, and collective groups supporting student learning and studies, and simply broadening the conversation away from the current perception that natural stone is an elite, high-end, expensive luxury. That is only one part of its story, and the rest was simply forgotten during the remains of the Industrial Revolution and the 20th century. We invested in significant new equipment and developed engineered solutions to create lines for mass production as close to mineral source as possible to ensure that costs ultimately will be low through economy of scale. And we have begun steadily progressing some really interesting projects with clients mostly inspired by both the exhibits and the growing conversation throughout the architectural and construction industry. With inspiration from post-war Europe and occasional load-bearing examples built in the UK over the past few years, and of course Group Works Clerkenwell Place and Finchley Road extravaganzas, plus the recently unveiled design centre Earls Court Stone Demonstrator project, built with a 90% reduction in carbon by Pierre's Stonemasonry Company, using natural stone exoskeleton beams, floors, and clad in UK natural stone bricks to demonstrate the future in natural stone. We feel that a new generation of perception continues to grow. And we thank you all for allowing us to share this further with you today. Thank you very much for listening.
That's great. Thank you, Marcus. More questions to follow at the end. We'd now like to introduce Pierre for the second half of the talk.
Hello. Hold on a second. So now I'm starting the broadcast, so please bear with me. Time for me to go on PowerPoint. Up. So sorry, it was all prepared, but time to Slideshow. Here we are. Can you see my screen, guys?
Perfect.
All good?
Can see
Yeah,
it.
perfect.
Super,
Yeah.
thank you.
Excellent. So thank you very much. Glad to have that great slide deck by Marcus, and starting by where it all began, which is very much the stone quarry. And what I'm going to talk about is, now that Marcus has put the foundation of how stone could be back into the fabric of modern construction. Another possibility is prefabrication. And prefabrication that would come through a reinforcement of rebars, post-tension cables, and so on. So I think it's very simple. The premise is very simple: is that we tend to forget that quite a few of our building in the last 2,000 years had some sort of iron reinforcement. Not as much as concrete as in reinforced concrete as with rebars and so on, but quite in some key condition, iron reinforcement was fitted into the construction. You can see from the left hand side, you've got the back of Beauvais Cathedral with these iron bars just stopping any wind loads, toppling the flying buttress. You've got a sort of interesting placement of rebars, iron rebars in Château de Vincennes. But also, if you go to Paris and you go and visit the Pantheon, you will see as well a network of reinforcement using rebars and made of iron at the time, of course, but just showcasing how people started to see stone as a material that could be reinforced with other material. And here I can introduce you to Mr. Fressinet. For people who don't know him, he is a French engineer who decided to push the market for reinforced concrete using post-tensioning of cables into a concrete structure, may it be floor slabs or bridge and so forth. And the system is very simple, is that if you take a lump of concrete or a lump of stone, they are both very similar system. What I mean is they work very well in compression. So what you do with reinforced steel or post-tension pretension steel, pretension concrete, is just to reinforce it by adding a sort of artificial reinforcement that would be steel rebars, and of course, as in the little pictures in the middle, you could see how you could put slabs of concrete, for example, or element of concrete, and just reinforce them with a cable and applying pressure on both sides to keep it strong and resilient. So if you can do that with concrete, why not do it in stone? And as on the very last pictures on the right-hand side, you can see the sort of system that we put in place and kind of standardized to a point where you could get beams, columns, and so on done with exactly the same system of prefabrication. That was very popular. That was an idea that was popular in the 1950s France, and in one occasion, because of the popularity of the concrete, the reinforced concrete, they tried to make it to make it valuable into the stone industry, and as such, they did an 8-meter long beam in 1950s with exactly the same premises of having a cable and rebars going all through this beam, just tensioning the cable and compressing the material. It went really well. It was, of course, a good answer to a more sustainable way of building, but unfortunately, it didn't go further. And it's only in 1968. So 10 years later, that this beautiful innovative structure was built. Here you can see a beautiful stairwell, all made of marble slabs. That those landings are all load-bearing stone landing, reinforced with post-tension cable, prefabricated, and then brought on site as one piece. And linked by those landing being linked by also post-tension staircase, prefabricated staircase that we are just then linking each landing. It was, of course, very much popular in the UK since 1994, with starting from the left, Michael Hopkins building using post-tensioning on Hutton Stone, but then the beautiful Portocullis house in London using this time prefabricated sandstone from Northumberland, I believe, all prefabricated and sent on site as columns. That's with Arup. And finally, a project by Eric Perry in central London using Portland limestone, again prefabricated columns, load bearing, so they support the edge of the concrete slab, and of course just prove again that this system is a valid answer to concrete columns. Now, some project of course were taking place in Italy. On the left-hand side, you can see the beautiful arches from Padre Pio Church, designed by Renzo Piano in the south of Italy. It is a seismic area, and those arches again are reinforced with steel cable and holding the roof and helping to support the full roof system. Finally, in Marseille, in Gare Saint-Charles, you can see this beautiful colonnade made of on-site tension local limestone. Right, so that brings us to the sort of the basis of history on and post-tensioning and reinforcement and prefabrication. And you can see two interesting key time in those sort of construction. You can see the beautiful Peter Rice pavilion. You can see these arches which are post-tension externally. So what you are seeing here on the left-hand side is just simple members of granite being produced off-site and installed as one big square, and the arches being held in place by the weight of the roof, which externally tension the whole arches. And finally, Arup again in 2024, finishing the 7th tower made of sandstone collected all over Europe, again all prefabricated. So those is to showcase how reinforced stone and prefabrication is of course key to putting back stone into the modern construction. Stone as a commodity, not a luxury. That's very much something we've been trying to push in the last 15 years. I think what is interesting is that when talking about stone, and as Marcus was saying, they are all very much local quarries, and as such, in pre-1900, architect engineer used to have a very good knowledge of local stone and very intimate with the material, and as such was able to say that this sort of firm stone should go into the plinth, maybe also into the windowsill, but that other part where there is less demanding condition, could it be made in a softer bed of that same quarry? So specification is key, and again, with this sort of very key specification, there is another aspect, as Marcus was talking about, the stone changing from the front of the house to the back of the house, and it's something we've been losing again in the last 30 years. We've been going a lot more about grade A, super selected material that was going to be used for surface finishes, cladding and flooring, either by just having concrete getting a lot cheaper. Those other grade B, grade C, and grade D disappeared. But if we were going to be a lot more intelligent in the way we extract our stone, we could use prefabricated stone for grade B. So it would be a stone that could be, pitted with some veins and so on. Then the large format grade C could be the result of a stone that allow a bigger module. And finally, grade D would be, as Marcus was explaining, making very sustainable brick that would allow with this 4 grade in place would allow a full use of the material instead of concentrating only on grade A. And that's very much what we did with the Clerkenwell building with Aminta Group work in 2016, is that again, we had the possibility to use a quarry where we could get big columns and big lintels, and instead of cutting them in small bits to suit, for example, a local context, which might not be relevant anymore, why not take those columns and those lintels as one monolithic element and just bring them to build an exoskeleton? And that was the mission that was given to us, to bring a sustainable material, affordable, and that could allow a fast build. So that Clerkenwell building was made as an exoskeleton. So you've got an exostructure, which is all load-bearing stone, and connected at the nose of each concrete slabs, which means that from the front of the building to the core, to the lift shaft, you have a totally unsupported structure. It is all held on the exterior by the stone lintels and columns. And again, to make it affordable, we followed what has been in France from the last 40 years, a material totally untouched after being cut. So as soon as it will be leaving, for example, Marcus' yard or our yard, there will be very little hand finishes that allow you to be a lot more efficient in the present, much more efficient cost-wise when building that affordable scheme or community center. So on the left-hand side, you can see a French building built in Southwest, where again the architect has decided to leave the tool marks. They are the tool marks of our time, you know, big circular saw. In the middle, it's 1950s France building building this how do you call that? This simple affordable housing scheme. And finally, on the right-hand side, it's Clerkenwell Close. This is the echo of the blade of the wire going through the stone and just being left totally untouched. So here you can see we've got the sort of natural prefabrication of monolith because these ones are not reinforced; they are just columns that coming out of the quarry, and you can see the black box on the nose of the concrete planks, the concrete floor that's going to be connected to the exoskeleton. So here on the left-hand side, you can see the connection from the nose of the floor slab, the concrete floor slab, to the back of the stone, and again the lifting of one of the monolithic elements. So this is a local limestone to Lyon on the Rhône. So here you can see a very efficient use of stone, only 100 cubic meters of stone, which is, you know, a very small amount of stone that we've borrowed from the crust of the earth. So again, a very efficient way of building, requiring very little water, because we use mostly grey water in a closed circuit. So that means the mobilization of water is very minimum. So for some key area where you might have a draw issue, that could be very useful. And here you can see the project in central London. So I think, again, as illustrated by Marcus, we tend to say humans are made of water, 90% of water or something like that. But I think modern humans are really made of oil. And I think in the last 100 years, we have seen us getting more and more hooked on oil and fossil fuel. And there is an interesting parallel to 1947 France and 2025 worldwide. Is that in 1947, as we needed to rebuild France and using as little as possible energy because it was very expensive, and wanting to use concrete, steel where it matters, which means mostly in infrastructure, building bridge, harbor, tunnel, and so on. They needed an affordable and fast build and a material that didn't need a huge amount of skilled labor force. And in 2025, we are very much exactly there with this affordable material that could be built quickly with unfortunately, less and less skilled workforce. And of course, we want our buildings sustainable. I think all here on the call, we all know how process our material are now, maybe it food or construction material. Everything is over-processed, everything is overcooked, overworked. And compared to leaving the earth doing that processing for us, why don't we stick to stone? Stone has been processed by Mother Earth in the last 135 million years. We might as well use what is already there, requesting as little as possible energy. And I think that's what happened to France in 1950. They just found out that 225 kilos of coal was necessary to produce 1 cubic meters of concrete, and 10 kilos of coal for just 1 cubic meter of stone, which, when you look at the difference in cost at the time, it was very, very cheap to, of course, build in stone. I'm comparing concrete to stone with the same sort of MPa strength, which is, you know, a sort of concrete CEM, 30 cm, you know, very similar kind of compressive strengths. And as such, the French government put subsidies, asked small quarry to be reopened and remobilize the local workforce to build on those quarries and produce standardized product. Here you can see a typical site in France in 1950s. Again, you know, that's the architect Fernand Pouillon. And here, all around France, mostly southwest, south, and northwest, you can see how France was using stone as a load-bearing material and in its facade. All that is 1950s to 1970s stone building. And the system works so well that even they built a 60-meter tower, still being used now 40 years later, 50 years later. That's a 70 years later, sorry. That's a 1950 tower in the center of Alger, the new district. And again, an incredible 60-meter high tower done with simple stone. So stone is loved in France because since the 2020 new policies created by the government of at least 50% of material coming from sustainable source for the building of new construction, with wood, it has been one of the preferred material to cut use of fossil fuel and decarbonize modern construction. As you can see on the left-hand side, you can see quickly the stone being cut at the quarry, sent to the gantry saw, then load up on a truck and sent to be fitted on site. So all over France, you see some beautiful natural stone structure being created, all being structural, all being also cost-driven. Those are sustainable building community centers. They are, you know, very much buildings where cost is at the heart, and as such, most of the studies are showing a very similar price, if not sometimes lower than a concrete structure clad in stone or other material. Here again, a few affordable project in France and Swiss. In Swiss on the left-hand side, and on the right-hand side below, it's one in Spain. So community centers, as I was saying, but also office block, affordable housing, research centers. All those are building made of natural stone as a structural material. So very, very little concrete overall. Now, crime and sediments. I'm going to speed up to leave at least 10 minutes of chat. Where to specify stone? So, of course, we could see that facade can be by default where most of the carbon is. But in fact, in some floor slabs and mostly and also foundation, that there is a huge amount of carbon used. And so, at the Stone Masonry Company, we thought, well, why not taking all the lesson learned from post-tensioning and reinforcement, take all the wonky vegetables that nobody wants, all the unloved stone, add the rationalization of architecture of modern time. And with this sedimentary stone, with those fossils, why and that artificial compression, very much like an engine to make it much efficient to in its use of fossil fuel. Why don't use less fossil fuel, a lot more fossil, so that we can supercharge our building? So I hope that was not too much of a long expose on what we are trying to achieve. But the fact is that we believe that by prefabricated and reinforcement of stone, we can come up with a system that could be also extremely economical and saving space in its footprint, and of course being very resilient and bringing a longevity that some modern building cannot. So the processing of reinforced stone, as we practice it at the moment, is very simple. We just check its integrity and capacity. We cut it, we drill it, then we bring it on our assembly line where we reinforce it. Reinforce it with rebars. We tension it and then store it and wait for the order so that we can shift it and send it on site. So the system is very simple. We just want to give the architect and the main contractor, as well as the engineer, a sort of kit toolbox where you would be able to pick up your beams, your floor slabs, your columns, have it linked each other by using mechanical fixing, very similar to what is done in the CLT industry, so that you don't have to be a stonemason to fit those structure. And the hook time in the lifting of one columns, it's 3 times quicker than just lifting one stone after the other to create that very same columns. As we are pushing for the use, as well as because of course stone, most stone are fireproof, and as such offer a very interesting alternative to CLT floor in some cases. The prefabrication, again, it's to speed up the construction process. And as Marcus was saying, we are very pleased to have done now, along with some stone suppliers in Europe and the UK, proving that those material are worth looking at again. That beautiful stone material, that by prefabrication and facilitating its specification, we can make a big difference in modern construction. You can see here, if you can fit floor slabs in concrete or wood, you can do exactly the same for stone. Here some example of stone floor slabs and ceilings, all load bearing, of course. Our prefabricated staircase. I'm just going to be moved a bit here, but I think if we look at all these things that augmented stone, natural stone can bring, from structural performance to impact on natural resources, fireproofing, I think there is a magnificent case for reintroducing stone, developing some very simple scheme like this one that we are working in the UK, very similar to the stone demonstrator in Earl's Court. And if we could start to see all that difference of colors, of textures embraced by the general public, so that we can accept again that amazing diversity of material, so that we can waste less material, I think that would be fantastic. And we would reintroduce a new vernacular. As Marcus was speaking of Edinburgh and the north of England, you don't build your granite or sandstone house like you build the one in Bath or Cornwall or Dorset or London. So I think it would be interesting to bring back a sort of more regional identity through the different innovation that can be used between the north, south, and west and east of the country. There is plenty of different strategy now to use stone, a variety of solution from exoskeleton to just simple stone column reinforced to stone walls. We do, of course, now foundation in stone. That's something that we can reintroduce. Composite material with waste material from Hutton, all the stone that nobody wants and cannot fit into the brick system. Maybe we can use it as a sort of giant terrazzo concrete system. We are developing the geosource rock block as well, very similar to the breeze blocks system that is in place. I'm going to pass that this one, but I think let's not forget the last thing is that it's a material that is when brought in full thickness, when this put in full thickness on site, it allows you to reuse it again and again, to pass it from one generation to the next with as little as energy needed. You know, here you've got from Paine in London, you've got the spare parts of London. All that stone is going to be reused, again, using very little energy. And I think that, you know, altogether, architect, engineer, manufacturer, quarry owner, we could solve a lot of problem before 2030. Cutting emission of concrete, cutting on sand, cutting on use of water. I think there is so much we can do with that material, and I think that any material should be seen as a sacred material. We should be a lot more conscientious of when we dig, when we grow, what we do with this material. And I think it's what we are trying to do either at the Stone Collective with Marcus and all our colleagues at the Stone Collective, but also, of course, with our business at the Stone Masonry Company. So here we are, guys. I'm going to stop sharing. Stop presenting. So here we are.
Thank you, Pierre. That was great. There's been a couple of questions in the chat which have mainly been related to cost. Obviously, that's I think the big question that everyone asks. The first one is related to general construction methods against steel, concrete, timber, etc., which you touched a little bit on France and Switzerland. In the UK, how do you see that comparing with the costs against these current construction methods?
All the projects I've shared, that's in France, Switzerland, Spain, I've got exactly the same cost as it's strange to say that, as a traditional way of building, which is concrete flame cladded in stone or bricks or whatever. So cost is key. These construction are made of stone that nobody wanted, you know, discarded stone, the wonky vegetables, which make it a lot more efficient cost-wise. But those are buildings that are built for and by councils, you know, regional council. So money is very important for those people. So they are not going to spend 40% or 50% more on those buildings than necessary. And also, and that Marcus can come back on that, but stone is extremely resilient. You know, we were not building for 50 years. We are building for 100, 150 plus. I think people don't realize how 50 years come around the corner. 50 years in the building industry is ridiculous. We should be building for a lot more than that, and we should stop a bit. We should slow down this sort of fast construction system. Marcus, I don't know what you think.
Yeah, well, I think all of that, and I also think that you know, it's worth bearing in mind that if you go to any average stone supplier, they will currently today sell you, let's say it's a 140 high, random length, 100 mil on bed, split faced walling block. So like a random length brick of some description. They will sell you that comfortably for £60 a square metre. There are 60 bricks to a square metre, clay bricks, which makes that brick £1 a brick, which is by and large a very competitive price for your average fair-faced brick. So it's not an absolutely cheapest of cheap brick, but it is nevertheless comparable with your average nice brick. Now, a clay brick can be £1, it can be £3, but nevertheless, there is a walling product that's existed for most of my career that is already then as cheap as a brick. And yet we perceive in house building, when you think about house building just as a view, we perceive stone to be the expensive option, when in fact it's actually just the same price as a brick. You could buy random walling stone for less than that. You could buy that for about 2/3 of that price. So that does put that down at a price of a cheap brick. So it's about perception, and it is about the idea that we've just forgotten that as long as you forget about range in material, that natural stone is it ought to be highly competitive. The other thing to say is that in a stone yard like my own, it will produce 0.14 cube per hour off of each of the saws. So it will produce about 1.2 cube per day. If you go to a unit size that is 400 mil thick, let's say, as a block size thick, then as opposed to say 40 mil, and you stop rejecting it because it's got some visual iron stain mark on it or something, then my factory would produce something more like about 7 to 9 cube a day instead of about 1.2, which means that if the average price of stone in the UK at the moment is, let's say, somewhere in the region of £2,500 up, depending on where you are in the country, it ought to be able to sit sub £1,000 a cube. And if you do build that building with a 400 thick wall, you take out all the steel and the concrete that you were going to have in that wall build-up. So you save money in that regard. And there are, finally, just to say, because of the compressive strength of stone, if you take the brick as an example, what some of the architects that are working on bigger projects have worked out is that you no longer need shelf angles on these buildings, because the stone has the ability to support the inner structure like the clay equivalent didn't. And just in that one move, that makes the stone more competitive than the brick, by the things that you don't have to use because you are using the stone.
Thank you, Marcus. There's a couple more questions here, some more cost related. One for Pierre, which is in terms of pre and post tensioning, is there a difference in cost, or is it just some's on site, some's in factory, and it's more sort of condition based? Sorry, Pierre, you're on mute.
It's condition based. It's condition based, of course. It depends on the context. But what we are trying to do is lining up on the cost of CLT plus 10%. So we are trying not to to take some share of these the cost of innovation by ourselves. But at the moment, we are trying to line up, as I say, CLT plus 10%. That's what we want.
Don't think we're going to have time for all these questions, so maybe just throw one more in the mix for now. And would it be okay if we share some questions with you after?
Of course.
Of course, yeah.
One other question was about the sort of structural engineering aspects, with understanding of what's required for designing structural stonework as opposed to concrete or steel. But it's being understood mainstream, and you were talking about maybe a toolbox aspect of these systems being readily available to people. How do you see this from both of your perspectives in terms of understanding for specifiers and what can be done?
You want to start, Marcus?
I was hoping you would, because I wasn't quite sure what the question was.
The question in the chat was, do you think the structural engineering aspects required for designing structural stonework as opposed to concrete or steel are well understood enough in mainstream, or is this more specialised?
Yeah, so it seems amazing to Pierre and I that it seems often not understood that we have to go through stringent testing of our material because we have to adhere to British standards the same as everything else does. And we also, for most masonry, we have to adhere to CE marking, which requires a legal declaration of performance. And that means that all of our material has testing, sometimes every 10 years, but for the key tests every 2 years, which means that we can give you flexural strength, compressive strength, freeze thaw, all of the elements. And often we hear engineers say, we know how to specify concrete, we don't know how to specify stone. And yet once you just give them the data that we have to supply by law for our material, it's very easy to specify what size that lintel needs to be, what size that column needs to be. You know, and I think that is becoming, because of this broader conversation that we've been having through the Stone Collective and other routes over the last few years, I think that is becoming more obvious to everybody now.
Just as Marcus was saying, I think, unfortunately, I mean, it's not unfortunately, but I think if we really want to engage at scale with reduction of carbon and fossil fuel, we need to create new codes. How do you call that? To bring an alternative code using those material, may it be wood, may it be earth, may it be straw, but we'll have to go through that, because it's not fair for the engineer to take all the risk and do all the legwork. We need through the Stone Collective or any other initiative, just to make the life of the engineer a lot easier, and so that specification it's much faster. But that's exactly like it has been done with wood and CLT 20 years ago. You know, just trying to work on that you know, pinch point, so that we can help developing more quarries and more stone for construction.
Just to add, Pierre, also, you know, at this moment I think there's 17 or 18 different academic studies going on at this point, testing and all sorts of things, where we see gaps in that information that is required by engineers. We are actively working with people to fill those, to provide you with that confidence. And the other thing just to say is that whilst there are a few of us making stone bricks now, some in the UK, some in Europe, rest assured that all of our colleagues in the industry are sitting watching with interest as the projects develop. And the moment it becomes exciting for them, they will all start to produce them. So your opportunity for, you know, competitive choice will only grow within this conversation.
Yeah.
I think that's probably a good point to end. We're just past 2 o'clock. Thank you both. It was great for Marcus to hear about extraction processes and particularly stone bricks and where they're going, and Pierre about the possibilities in a modern context for load-bearing stone structures. Our next talk is on Monday the 1st of December, where Jim Hart and Ian Ramsey will be presenting the embodied carbon of slate. So please sign up and look forward to seeing you in a month's time. This talk will be available on YouTube soon for recording, and we'll try and get the rest of the questions to Marcus and Pierre.
Sorry, Stephen, just one thing, and I think Marcus will be the same, but thank you very much for organizing this stone support, this stone initiative and so on. We cannot do it without you, and really it's you know, it's with all our heart that we thank you for giving us this opportunity and this full range of talk about stone. Really, thank you very much.
Yeah, thank you.
Thank you.
Thank you.